Hello everyone, welcome to Maths Wheels. In this session, we shall learn about the geometrical meaning of zeros of polynomial. This is part 2 of polynomial chapter. In part 1, we have already learned basics of polynomial. So now, let's get started. Now, when we say geometrical, it corresponds to graphical representation. In this particular concept, we will be learning about graphical representation of linear polynomial, graphical representation of quadratic polynomial, and also the cubic polynomial. And we will find the zeros of polynomials using these graphs. Now, let us revise what we learned about zeros of polynomial in earlier classes. What is zeros of polynomial? It is the value of variable for which value of the polynomial becomes 0, right? Suppose we have a polynomial p of x, and if we substitute any real number k in place of x, and if it gives you the value of polynomial as 0, so p of k becomes 0, then this k is called zero of polynomial. Zeros of a polynomial, it is the value of a variable for which value of polynomial becomes 0. Now, suppose we have a linear polynomial of the form ax plus b. This is the linear polynomial, right? The degree of the variable x here is 1. So this is the linear polynomial. Now, how do we find the 0 of this polynomial? We simply equate it to 0. So what will be the 0 of polynomial here? X equals to minus b by a. This is the 0 of polynomial. Now let's take an example, 2x plus 3. This is the linear polynomial. Now to find the 0 of polynomial, we equate it to 0. What we get? We get x equals to minus 3 by 2. This is the 0 of the polynomial. So this is how we find 0 of polynomial. Now the same thing we will be doing using graphs. Using the graphical method, we will find zeros of polynomial. Now let's take the same polynomial 2x plus and let's find the zeros of this polynomial. Let's represent it as y. In classes, we already learned how to plot the graph, right? So as you can see on the screen, this is the x-axis, this is the y-axis, and we have the measurements there. 1 centimeter equals to 1 unit as a scale. Plot the point on the graph, we need x coordinate and y coordinate, right? The graph for linear polynomial, we need x coordinates and y coordinates that are x values and the y values, right? Take some random value. From 0, we move on left and on right. 0 to the left, 1, 2, and to the right, minus 1 and minus 2. So 0, 1, 2, minus 1 and minus 2. These values we generate. We said we need x and y values to plot the graph. I am writing here as x, y, and x, y, this will be the coordinates of the points. So for x, just now we said we take random values. I am writing here minus 1, minus 2, 0, 1, and 2. Okay, so for these particular values of x, we have to find the values of y now. How we find it? Just put the values of these x into this polynomial and we get the values of y. So let's take first value, that is x equals to minus 2. Just put this value in polynomial. What we get y equals to minus 4 plus 3, that is minus 1. Write the value here at y. So at x equals to minus 2, we get y as minus 1. Similarly, find all the values of y at these particular values of x. We have now found all the values of y at these particular values of x by putting the value of x in the polynomial. So what are the ordered pairs, or we can say the coordinates we get here? Minus 2, minus 1. Next, first one is the x coordinate and next is the y coordinate. Similarly, minus 1, 1, 0, 3, 1, 5, 2, and 7. These are the x and y coordinates we got to plot the graph of this linear polynomial. Plot points on the graph using these coordinates. Let's take first values, minus 2, minus 1. So minus 2 on x-axis and minus 1 on y. This is the point. Okay. So this is the point here. Next is minus 1, minus 1 and 1. This is the point here. Next is 0 and 3. This is the point here. Then we have 1 and 5 here. And 2, 7. So if you plot, it will be somewhere like this. So now let's plot the graph. Let's join these points. So what we get? We get a, so if we do it on a graph paper, we will get a perfect straight line. So if you see, the graph of the linear polynomial is a straight line. Now if you observe, this line is cutting the x-axis at some point, right? This is the point. This is the point where it is cutting the x-axis. So we need to consider this point of intersection to find the zeros of this linear polynomial. What is the zero of this polynomial? The x-coordinate of a point where the graph is cutting the x-axis. So this point we are considering. And what are the x-coordinate and y-coordinate of these points? Y-coordinate will obviously be 0, and this is lying on the x-axis. And since it is cutting the x-axis at point between -1 and -2, so what will be the x-coordinate? It is -2 and -2, average of -1 and -2. So it will be -3/2. So this is the x-coordinate of this point, -3/2. This x-coordinate of a point, -3/2, is called a zero of a polynomial, of a linear polynomial. This is how we find the zero of a polynomial using graph. Next is graphical representation of quadratic polynomial. Let's take quadratic polynomial where -3x - 4. Highest power of the variable is 2, and this is a quadratic polynomial. Find the zero of the polynomial using graph. We need to follow the similar steps as we did for linear polynomial. So let us find x and y coordinates for quadratic polynomial. Let's take random values for x. So -2, -1, 0, 1, 2, 3, 4. And let's find the values of y for these values of x. So when x equals to -2, what will be the value of y? -2 square -3 into -2 -4. That will be 6. So the value of y we get 6 when x equals to -2. So put 6 in this table. Now similarly we have to find other values of y for these particular values of x. What values we get for y? 0. So what will be the x and y coordinates? -2, 6, -1, 0, 4 and 0. Now we have x and y axis on the graph, and we need to plot the points we got, the x coordinate and y coordinates. First point we have -2, 6. -2 on x axis and 6 on y axis. Suppose we have 6 here. So first point will be here. Second -1, 0. So it will be here. 0 -4. 1 and -6. 2 -6. 3 -4. And 4, 0. So let us join all the points. Let's see what we get. So what is the shape we got? It's a parabola. Now since we observed that the shape of the graph is stopping at x-axis, we can take one more value of x and find the value of y. So we can exchange the shape of the graph. So let's take one more value for x and check what value we get for y. So if x is 5, what will be y? It is 6. So what will be the x and y coordinate? 5 and 6. Let's plot this point also, 5, 6. So here this will be the point. Let's join this with the earlier point. So now the shape we get is a perfect parabola. So observe the graph of this quadratic polynomial. This graph is cutting the x-axis at 2 points, this and this. What are the coordinates for these points? First one, this one is -1, 0, and this one is 4, 0. What are these points? These points indicates the zeros of polynomials. Or in simple we can say the x-coordinate of the points where the graph cuts the x-axis indicates the zeros of the polynomial. So if you observe this -1 and -4, these are zeros of this quadratic polynomial. So in general we can say if the graph cuts the x-axis at 2 points, then that polynomial has 2 zeros of polynomials. Like in this case, -1 and 4, these are the 2 zeros of polynomials. Now the shape of the parabola can be like this also, the inverted parabola. So if you see, these are the 2 points where this graph cuts the axis. So you can see there are 2 zeros of polynomials for this graph also. Now what if we have these two conditions, like if we have the parabola like this, where the parabola is cutting the axis at only single point, or we can say it is only touching the x-axis. And we have another case where we have the parabola of shape like this, where the parabola is touching the x-axis at only single point. So what will be the zeros of the polynomial, or we can say how many zeros of polynomials will be there? There will be only single zero of polynomial for these type of parabola touching the x-axis at only single point. Now if we take another case where parabola and the x-axis has no connection at all. So this is one case, and another case is one parabola. Here this parabola has no connection with x-axis. Can we find the zeros of polynomials in these two cases? No, because to find the zeros of the polynomials, graph should cut the x-axis. So in these two cases, the parabola has no connection with the x-axis at all. So there are no zeros for this type of graph or for this type of polynomial. You can see it has no zeros. So we have learned 3 cases for quadratic polynomial. Case 1, the graph cuts the x-axis at 2 points. So it has 2 zeros of polynomials. Case 2, the graph touches the x-axis at only single point. So it has only single zero of polynomial. And the third case, the graph and the x-axis does not have any connection. So it has no zeros of polynomial. So in general, what we can say, a quadratic polynomial can have maximum of 2 zeros. Can either have 0 zeros, 1 zeros or 2 zeros, but maximum of 2 zeros. So that's how we find zeros of a quadratic polynomial. Let's move on to cubic polynomial. Let us take the cubic polynomial x cube minus 4x. Let's represent it as y, and to plot the graph we need x coordinate, y coordinate and xy. We need to follow the same steps as we followed for linear and quadratic polynomial. Let's take the values for x, -2, -1, 0, 1 and 2. And let's find values for y. So let's calculate the value of y by putting value of x in the polynomial. Let's put -2 in the polynomial. So what we get, take x as -2. So we get y equals to 0. So for x equals to -2, we get y as 0. Let's put that in table. Thirdly, we need to find all the values of y at these particular values of x. So we have now found all the values of y. So what will be x and y coordinates? Let's write it here. -2, 0, -1 and 3, 0, 0, 1, -3, 2 and 0. Now if you observe the values of y, these values are 0. So at x equals to -2, x equals to 0 and x equals to 2, we got values of y as 0. We can say about these values, these are nothing but zeros of our polynomial. Let's write it, zeros of polynomial, -2, 0 and 2. Let us plot these points on the graph to find the zeros of polynomial. Let us plot it on graph. First point is -2, 0. So it is here on x. Second point we have -1, 3. So it is on here. We have 0, 0, it's here. Point is 1, -3. 1 on x-axis and -3 on y. So it is here. Point is 2, 0. 2 on x-axis, 0 and y. So it is here. Now let's join all these points and let's see what is the shape of the graph we get. So this is the first point, this is the second, this is the third, fourth, and this is fifth. So this is the graph we got for y equals to x cube minus 4x. If you observe, this graph is cutting the x-axis at 3 points. First, second and third. What are these points? -2, 0. This is the origin, 0, 0. And this is on x-axis, 2, 0. Now if we just take the x-coordinates of these points, that is -2, 0 and 2. What are these? These are the zeros of the polynomials. So simply we can say the x-coordinates of the points where the graph is meeting the x-axis gives you the zeros of the polynomial. This graph is cutting the x-axis at 3 points. So this polynomial has how many zeros? 3 zeros. Now let's take one more example of cubic polynomial, that is x cube minus square. So the graph of this polynomial we get is something like this. If you calculate all the coordinates, x coordinates and y coordinates, and if you plot the graph, you get the graph like this. Now if you observe, this graph is cutting the x-axis at 2 points. So how many zeros will be there for this polynomial? There will be 2 zeros of polynomial, and the x-coordinates of these points will give you zeros of polynomial. Now let's take another example, that is cubic polynomial x cube. So if you plot the graph for this polynomial by calculating all the x and y coordinates of the points, the graph of this polynomial will be like this. So if you observe, this graph is cutting the x-axis at only 1 point. So it will have only 1 zero of polynomial, and the x-coordinate of this point will give you the exact zero of polynomial. To summarize, for a cubic polynomial, how many maximum number of zeros can be there? There can be maximum of 3 number of zeros. So if we want to summarize what we learned, for a linear polynomial of degree 1, it can have maximum of 1 number of zeros, maximum number of zeros. For a quadratic polynomial whose degree is 2, it can have maximum of 2 number of zeros. For a cubic polynomial with degree 3, it can have maximum of 3 number of zeros. Here we have completed graphical representation of linear, quadratic and cubic polynomials. I hope you have understood it clearly.